doing now. And here we go. So there's that information again about if you don't wish to be seen or heard, change your name on the screen and blot out your video. Anyway, so what I want to do today, first of all, thank you those of you that now got the correct ID address. My apologies about that. I don't know what I was doing. We're going to look at section 6.2 today, but first of all, if you have any questions from last night's homework, we could look at that. And if we need to go into WebAssign and look at it there, we will. Or if you want to just tell me the problems, I can work them out however you want to do that. So, are there any questions from section 6.1 from yesterday? Alrighty, I will take that as a no, and we will go on to section 6.2, which is factoring trinomials in the form x squared plus bx plus c. Now, what is a trinomial? It's an expression that has three terms, or an algebraic expression with three terms. So, for instance, x squared is a term, bx is a term, c is a term. So that is a trinomial. Now, notice that there's no letter in front of x squared. So what we're dealing with here is a trinomial where the leading coefficient is a 1 or an implied 1. B and C imply that there might be something there other than a 1. So for instance, x squared plus 5x plus 6 would be a trinomial that's in this form. Do you have any questions about that? I'll take that as a no. All right. Now, what I want to do is I actually want to go back to chapter 5 of the textbook, not literally, but in chapter 5, we learned about foiling or multiplying two binomials together. Let's say we had something like x plus 3 times x plus 2. And to multiply those two binomials together, we would take x times x and get x squared, and then x times 2 and get 2x. Hang on a second. I want to move this over here. And then 3 times x would be 3x, and 3 times 2 would be 6. Then, combining like terms in the middle, we get x squared plus 5x plus 6. So back in chapter 5, we multiplied two binomials together to get a resulting trinomial. What we're going to do here today is we're going to go the other direction. We're going to start with a trinomial and we're going to pull it apart into two different binomial factors. Well, let's look at the mechanics of this problem and see what we can discover. Going this way, this times this, in fact, the whole FOIL idea, first times first, that's F, and then it's what? Outer times outer, that's the O for the outer. Inner times inner is I, and last times last is L. That's where we get FOIL. So first, outer, inner, last. Why am I bothering to label it that way? Because of this. Where did this come from? It came from the F, that is the F, the first, right? This times this gave us that. So going the other direction, this times this gave us that. So that gets split up into an X and an X. All right, that's the easy part. Now, where did this come from? The L, the last. That came from the last times the last. So that means that this number, I'm going to put a question mark there, times this number, those two together had to give us a 6. Okay, so we need a product that equals 6. Now the problem is there are a lot of different pairs of numbers whose product is 6. 6 and 1, 2 and 3, -6 and -1, -2 and -3. So I need more information to know whether we're talking about 6 and 1, -6 and -1, 3 and 2, -3 and -2. Those are all pairs of numbers that could go here and here to give us a positive 6. But if we go further, we discover that this, where did that come from? That came from the oi. Any Australian soccer players here? Oi, mate. The O and the I. Okay. Sorry, no Australians here. So this came from these two numbers here. So that means this has to be the sum of these two numbers. So I need a sum that's equal to 5. So I'm looking for a pair of numbers whose product is 6 and whose sum is 5. Well, looking at these numbers here, oh, there's a pair of numbers whose product is 6 and whose sum is 5. So what goes in the place of the question marks? Come on, we'll get this to work. There we go. So I'm going to put a +3 and a +2, which of course, if we look back over here, we see that, well, yeah, that's the correct answer. But the next example, we're not going to have the starting point. Okay. So basically, when I have a trinomial in this form, I'm going to take that leading term that has a coefficient of 1 and put it at the front of each of my binomials. Then I'm going to look for a pair of numbers whose product is this and whose sum is that. And those two numbers are going to go right here to complete the problem. Let's see if we've got that. Okay, so here is a new problem. Y squared plus 4y plus 3. The directions say factor. This is a trinomial with a leading coefficient of a 1. And it's in standard form or descending powers. Y squared followed by y followed by no y at all. So splitting it up, the y's are going to go in the front. I'm looking for two numbers whose product is 3 and whose sum is 4. Product, sum. Any questions yet? All right. So two numbers whose product are 3. Well, how about 3 and 1, -3 and -1? That's really about it. Oh, but these two numbers also have a sum of 4. 3 times 1 is 3. 3 plus 1 is 4. So I've got a +3 and a +1. Let's check our work. Let's take the answer and FOIL it back together and see what we get. We get y squared plus 4y plus 3, and that checks. So this is the correct factorization of that original trinomial. Any questions there? Okay, let's continue. N squared minus 7n plus 10. We have a trinomial in standard form. It has a leading coefficient of a 1, so I'm going to split it apart like this and this. I need a product that's a +10 and a sum that's a -7. Well, let's see. A product of +10 could be 10 and 1, 5 and 2, -10 and -1, -5 and -2. Ah, here's the two numbers. But wait a minute. We could have saved ourselves some time. To get a positive product, I'd either have to have two positives being multiplied together, or two negatives being multiplied together. But to get a negative sum, I couldn't get that from adding two positive numbers. So really, I didn't need to even consider those. Looking at it ahead of time, I could predetermine that the signs of the numbers would have to be the same to get positive product, but they'd have to both be negative. And so I would get this answer. Any questions about what I just said there concerning signs? All righty, let's take a look at another problem. Let's see here. U squared plus U minus 42. We have a trinomial in standard form with a leading coefficient of a 1. So we're going to split it up like that. We need a product that's negative 42 and a sum that's equal to what? What's the coefficient of U? Right here. What's the coefficient there?
1.
Good. So I need a product that's negative 42 and a sum that's positive 1. Now, to get a negative product, we've got to have a positive and a negative, or a negative and a positive. Two positives would give us a positive product. Two negatives would give us a positive product. So to get a negative product, I've got to have one of each, a positive and a negative, or a negative and a positive, okay? But those same two numbers, when I add them, have to have a sum that's a positive 1. So that means these two numbers, the positive has to be larger than the negative by 1. Let's see, what times what is 42? 6 times 7. Oh, so if I had a positive 7 and a negative 6, that would give me a product of negative 42 and a sum of positive 1. If I used negative 7 and 6, I'd get the same product, but my sum would be a negative 1, so that wouldn't work. So plus 7 and minus 6. Any questions on that? So again, by looking and thinking about the signs, question? Nope. Okay, looking at the signs.
I had a question.
Yes.
Can you hear me? So
I can.
would it matter if you did -6 in the first quotations? Would it be the same thing? If you like swap?
That's a very good question. Can anybody answer that and give a reason why? I guess that's up to me. Yes, they're equivalent because multiplication is commutative.
Okay, thank you. I was just making sure.
Yep, so it doesn't matter because these are identical. We can put the plus 7 and the minus 6 in either order, as long as the rest of it was the same, because multiplication is commutative. You can multiply in either order. Good question. All right. Let's see here. Negative x squared plus 9x minus 20. And it says factor. Here we have a trinomial in standard form. Oh, but it doesn't have a leading coefficient of a positive 1. I alluded to this yesterday, that when we were going to factor something, we wanted our leading term to have a positive coefficient. So what I'm going to do at the very beginning is I'm going to factor out a -1, or just factor out a negative. So this is going to be x squared minus 9x plus 20. And again, I could write it that way, or I could write it like this, just putting a negative sign without the implied 1. Either way works, okay? So now I'm going to take this trinomial that's inside the parentheses and break it apart, an x and an x. Oops, come on. For 2 quarters, I've been trying to get this eraser to work for me, and it just never seems to want to. There we go. Sure, as soon as I say I can't do it, then it works. Okay, so I need a product that's 20, not -20, because we've moved on down to the next step, and a sum that's -9. Okay, so I'm not dealing with this anymore, I'm dealing with this. Okay, here we go again. To get a positive product, I've got to have 2 positive factors or 2 negative factors. Whoops. But to get a negative sum, I couldn't add 2 positive numbers and get a negative sum. So my 2 numbers have to be negative. So like -20 and -1, -10 and -2, -5 and -4, and of course, there they are. Now, you don't have to write down every possible combination, but if that helps you to see which one it is, in other words, if you can't immediately see that, oh yeah, 5 and 4, -5 and -4, write them down, that'll help. But it's one of those things that you get better at the more you practice. So again, you could write the answer that way, or you could write the answer that way, or you could even write the answer as we talked about earlier, commuting the 2 inside factors that way. Any questions there?
And the negative sign would stay outside the parentheses?
Correct.
Okay.
Or the -1, whichever way you want to go. Yep. Because it's, so we've got it factored completely. Okay. Let's see here. Let's take a look at this one. A squared plus 6ab plus 5b squared. Well, this is a trinomial. It is in standard form in terms of the variable a. Going from left to right, we have a squared in the first term, just a in the second term, and no a's at all in the third term. Now, it wouldn't be in standard form in terms of b, but as they say on the farm, if it ain't broke, don't fix it. This is in standard form in terms of a, so let's leave it alone and go to work. So we're going to have an a and an a. Our product needs to be 5, and our sum needs to be 6. Okay? Now, positive product, I've got to have 2 positive factors or 2 negative factors. Since the sum is positive, I can't get there with 2 negatives, so I'm looking for 2 positive numbers. 5 and 1, that's just about it. So it's going to be +5 and +1. Now, am I done?
No.
What have I left out?
The variables.
Yeah, the b's. The b's are gone, right? So how is that b squared going to get split up? Well, it's going to go here, and I'm going to change that 1 into a b instead of just writing 1b. So I'm going to have a plus 5b times a plus b. So my a squares get split up at the beginning, b squares get split up at the end, so my middle terms are going to have both a and b in them. So be careful that you don't forget that other variable if it shows up like it did here. Any questions? All right. How about this one? M squared plus m n minus 6n squared. So would it be safe to go ahead and do that, you think, with the n's?
Yes.
Good. All right. So my product is -6 and my sum is a +1 because there's an implied 1 here and there's a -6 there. My product is negative, so I've got to have 1 positive and 1 negative. But the sum is positive, so that means when I add those 2 numbers together, the negative swallows up most of the positive, but there's 1 left over. So my positive needs to be a little bit bigger. Well, I could do 6 and -1, but that would give me a sum of, what, 5? How about 3 and -2? That would give me a product of -6 and a sum, 3 plus -2 would be a +1. So it goes like that. And again, checking my work, m squared minus 2mn plus 3mn minus 6n squared, combining like terms, m squared plus mn minus 6n squared, and it matches. So here is my correct answer. And then I went on and checked it to make sure I got back to where I started. Okay. So here we have a trinomial. It's in standard form, but it doesn't have a leading coefficient of a 1, and it's not like a negative to factor out. But is there a greatest common factor of the whole trinomial?
3.
Yes. So we'll factor out the greatest common factor. Okay. So now inside the parentheses, I have a trinomial with a leading coefficient of a 1. So I'm going to get a 3 and a y and a y, and my product is going to be 6, and my sum is going to be -7. Now again, we're not dealing with this anymore. Now we're down here. So that's why I got 6 instead of 18 and -7 instead of -21. So just be careful with that. All right. Product is 6, sum is -7. To get a positive product, I've got to have 2 positive factors or 2 negative factors, but my sum is negative. So I'm looking at 2 negatives. How about -6 and -1, negative? Oh, that's going to do it, isn't it? So my answer, 3 times the quantity y minus 6 times the quantity y minus 1. And you'd leave that 3 outside. It's part of the answer. Be careful. A common mistake students make, they factor out the 3, then they take what's left and factor it, but in the final answer, they don't include the 3. That's like going to the airport and leaving your luggage there in the airport and taking off for Hawaii, and you left your luggage behind. That's not a good thing. Well, unless it gives you an excuse to buy all new clothes in Hawaii, but anyway. All right. Let's see here. How about this one? -m cubed plus m squared plus 56m. This is a trinomial. It's in standard form. Oh, not only does it not have a leading coefficient of a 1, but it doesn't start out with an m squared, does it? Is there a greatest common factor to all 3 terms?
M.
M. But in fact, rather than taking out an m, let's take out a -m so that we not only get rid of the m, but we get rid of that negative as well. So that gives us a leading term inside with a coefficient of 1, m squared. All right? So this is going to be what? Minus m minus 56. Is that right? Let's see. -m cubed plus m squared plus 56m. So far, so good? Product is going to be -56. Sum is going to be -1. So I got to have a positive and a negative, but the negative's got to be slightly larger. Think about, if we were sitting in a normal classroom, this is what I'd say. I'd say, why is it the person next to you is getting this really quickly and you're not? They know their multiplication tables. Okay, 56. What do you think of? What times what is 56? 7 times 8. So let's see, we'd have to have a -8 and a +7 to get a sum of -1. -8 times 7, product is -56, sum is -1. So I've got this and that. It's a lovely looking M. All right? Questions on that? Well, then we'll continue. y squared plus 100 plus 25y. This is a trinomial. What's wrong with it?
Is it that it's not in descending order?
Correct. So we're going to rewrite it y squared plus 25y plus 100. So now we have a trinomial in standard form with a leading coefficient of a 1. So we're going to take out the y's. The product is going to be 100. The sum is going to be 25. To get a positive product, I need two positive factors or two negative factors. But two negative numbers don't add up to a positive sum. So I've got to have two positive numbers. Well, let's see. How about 101, 50 and 2, 25 and 4, 10 and 10. It seems like I've missed it because this would give you a sum of 101. This would be a sum of 52. This would be a sum of 29. And this would be a sum of 20. And I need a sum of 25, which is right in here. Well, so this pair of numbers, one of them has to be between 25 and 10, and the other has to be between 4 and 10. Can you think of a number? Oh, there's less numbers between 4 and 10. Can you think of a number between 4 and 10 that goes into 100, like 5, 6, 7, 8, or 9? Does 5 go into 100 evenly?
Yes.
How many times?
1.
Oh, there we go, 20 and 5. Now, I drug that out a little bit because I'm sort of trying to start to introduce an idea of, if you can't see it right away, how to get there. And we'll keep working on that. Any questions on this problem? Alrighty. How about this one? Let's see. A cubed plus 5ab squared plus 6a squared b. Is this in standard form?
No, because it has to go a squared after the a cubed.
Correct. Somebody driving in a car? Keeps sounding like there's air rushing by. Maybe it's just all the hot air that I'm producing here. All right, so there's standard form. What would be next? Is there something we can take out?
Take out a.
Yes. So if we take out an a, we get a squared plus 6ab plus 5b squared. Oh, I'm going to split up those b's, right? Like that?
Yeah.
So now my product is 5, my sum is 6, positive, positive, 5 and 1. And I'm not going to bother to put the 1 in front of the b. I could put it there, it isn't wrong, but it isn't necessary. Math people tend to be lazy, efficient. Good to go on that one?
Yep.
Okay. How about this one? V squared plus 9v plus 15. Let's see. It's a trinomial. It's in standard form. There's no greatest common factor. Okay. So everything's looking nice and easy to start with. My product is 15 and my sum is 9. So to get a positive product, I've got to have two positive factors or two negative factors, but the sum is positive. So I'm looking for two positive numbers. So 15 and 1, 5 and 3. 15 and 1, that would give me a sum of 16. 5 and 3 would give me a sum of 8. Neither of those work. Are there any factors I've overlooked here that could possibly work? Nope, there aren't. So that means that this thing is prime. It doesn't factor. Okay? So this is called a prime polynomial because we can't pull it apart in the normal ways that we do. Okay? We can't factor it using real numbers and rational numbers and whatnot. Okay. Let's see here. Now we're just going to kind of mix it up a little bit. Here's some problems that pertain to yesterday's as well as today's homework. AB plus B plus 2A plus 2. It says, choose the correct method to factor each of the following. So we have 4 terms. This is not a trinomial. We're going to use factoring by grouping. So let's see here. Is there a greatest common factor to all 4 terms other than a 1? Doesn't look like it. So we'll split it up. The greatest common factor of the first 2 terms is a B. Leftovers are A plus 1. And don't forget, I need that plus 1 because I need to get back here. Okay. So over here, what am I going to want to have? I'm going to want to have a match to that. So what would I take out of there so I'd have an A plus 1 left over?
2.
So I'm going to have a plus 2. Now my greatest common factor is A plus 1, and the leftovers is B plus 2. To check my work, A times B is AB, A times 2 is 2A, 1 times B is B, 1 times 2 is 2. Let's see, I've got AB, B, 2A, and 2. The order's changed, but that doesn't matter because addition is commutative, just like multiplication is commutative. So A plus 1 times B plus 2. All right with that? Okay. 40c squared minus 12c. Well, this isn't 4 terms, so it's not grouping. It's not 3 terms, so it's not a trinomial. It's 2 terms. It's in standard form. Oh, is there a greatest common factor?
Would it be 4C?
4c. Let's find out. If we take 4c out, we'd have 10c minus 3 left over. Can we take anything out of 10c minus 3? No. So this is correct. Good job. So all we could do there was take out the greatest common factor. Okay. We good to go on? Take that as a yes. T squared minus 5t minus 50. So here we have a trinomial in standard form. It has a leading coefficient of a 1. So we've got a t and a t and a product and a sum. What's the product got to be? Negative 50. And the sum would have to be
-5.
negative 5. So product that's negative, I've got to have a negative and a positive, but my sum is negative, so I got to have a big negative and a littler positive. Let's see. How about negative 10 and 5? Would that do it?
Yes.
Yeah. Okay, so minus 10 plus 5, and we're done with that problem. Okay, let's see here. How about this one? Negative c to the 5th power plus 16c to the 4th power plus 80c to the 3rd power. Well, this is a trinomial, and it's in standard form. What's the greatest common factor?
-c squared.
Right, and good for you to take out. Actually, no, it's even bigger than that. Negative c
Cubed.
cubed. Good. So that gives us a positive c squared left over, minus 16c minus 80. Be really careful with your signs there. Factoring out a negative changes the sign of each thing that goes inside. Okay? So now, bring down the negative c cubed. We're going to have a c and a c. Product is going to be negative 80. Sum is going to be negative 16. Let's see here. So positive, a product that's negative, we've got to have one of each. The sum is negative, so the negative's got to be bigger. So how about like negative 80 and 1? Well, that gives me the right product, but the sum not so. Oh, but you know what? Negative 80 is even, so I could cut it in half and then double the 1. By cutting the first one in half and doubling the second one, I still get a product of negative 80. Well, this had a sum of negative 79. This has a sum of negative 38. How if we cut this in half and double that? Oh, now, this doesn't always work to where you land right on the number, but if you don't, if you go past it, then we get a situation like I had, let's see, where was it? Up here, where I went past the number, so I knew it was in the middle. So that's kind of where I'm going with that. Anyway, minus 20 plus 4. Any questions on that?
No.
All righty. Let's see. This one. M squared minus 8mn plus 16n squared. Okay, so we have a trinomial. It's in standard form in terms of m squared, no m at all. And it has a leading coefficient of a 1. No greatest common factor to take out, so I've got an m and an m. Oh, and I've got to have n's at the end, right? Product is positive 16, sum is negative 8. Positive product, I've got to have 2 positive factors or 2 negative factors, but the sum is negative, so I've got to have 2 negative factors. How about negative 16 and negative 1? No, that's not right. Negative 8 and negative 2? No, that's not right. Negative 4 and, oh, negative 4 and negative 4 gives me a product of a positive 16 and a sum of negative 8. Now, because these 2 factors are identical, got an awful lot of space there. I'm going to recopy that. I could write them like this, or I could write it like that, because I have 2 identical factors. So I can use this notation or that notation. Now, which notation is best? In this context, it doesn't matter. Later on, there might be a situation where we prefer the top one. There might be a situation where we would prefer the bottom one, just depending on what we're going to be doing. Okay. How about this one? M squared plus 3m minus 20. So this is a trinomial in standard form. It has a leading coefficient of a 1, and it has no greatest common factor other than a 1. So we're going to get an m and an m, a product that's negative 20, and a sum that's 3. To get a product that's negative, we either need to have a positive and a negative, or a negative and a positive. To get a sum of 3, that means that our positive number has to be bigger. So we're looking for a big positive and a little negative, okay? Since I'm looking for a big positive and a little negative, I wouldn't start out with negative 20 and 1. I'd start out with 20 and negative 1 as my first try, okay? Well, that gives me a sum of 19. That's too big. 20 is even. Cut it in half and double that. I still get a product of negative 20, and I get a sum of 8. 10 is even. Cut it in half and double that, and I get a product of negative 20 and a sum of 1. Well, once again, I've gone too far. This would be right in between there, wouldn't it? So that means, that's supposed to be a 10. That means that my two numbers, one of them has to be between 10 and 5. One of them has to be between negative 2 and negative 4. There's only one number between negative 2 and negative 4. What is it?
3.
Negative 3. Well, negative 3 times what is negative 20? There isn't an integer that's going to work. So what's my conclusion? Prime. Now, a mistake that people will make is they'll just make random guesses and they can't come up with anything, so then they say it's prime. You've got to have some kind of a system like I've got here so that I know I've eliminated all the possibilities, not just randomly picking numbers, but I you know, by moving down and this moving up, and then seeing that, oh, it's got to be in there, and nothing works. Okay. Let's see here. How about this one? Negative 3a plus a squared plus 2. What do we need to do here?
Take out a negative 1.
Take out a negative 1? Maybe. Maybe not. There's something else that's not quite right.
Oh, it's not in standard form.
There you go. So a squared minus 3a plus 2. So now we don't need to take out a negative, do we? Good. So we've got an a and an a. Product is 2. Sum is negative 3. Product is positive. I've got to have two positives or two negatives. But the sum is negative, so I couldn't use two positives. How about negative 2 and negative 1? That's really the only possibility, isn't it? So we have that. Alrighty. Well, I think I've tortured you enough for today, and I suspect you would agree with that. So I'm going to go in and stop the